Right, solid phosphorus and hydrogen can combine. So that tells us that these are reactants. And it's given us the formula for phosphorus. It's P4. Tells us it's a solid. And that's going to combine with hydrogen, which is a diatomic gas. And that's going to go through a combination reaction to form phosphine. And the formula for that is also given, PH3. And we're told that that's also a gas. All right, so let's balance this so we can do the stoichiometry. All right, so there's 4 phosphoruses on the reactant side. We'll need a 4 there. All right, now don't forget to distribute and update the hydrogen as well. So we have 12 hydrogens. We're going to need a 6 there. All right, so the coefficients are 1, 6, and 4. We don't usually write ones, but we'll write it for stoichiometry. Now we can follow the steps. Step 1. Usually is to convert to moles if we're not given moles, and we're not. All right, so first read the problem if you haven't. All right, it's given us information about hydrogen, and it's given us that information in liters. So we have that information in liters, and it's asking us to find information about another substance. That's what makes this a stoichiometry problem. We're not given moles, so we need to turn that measurement into moles. All right, so let's start with 0.42 liters of H2. Okay, always label your substance. And we want to get rid of liters, or we want to get rid of whatever unit they give us and turn that into moles. All right, to get rid of a unit, in this case liters of H2, we need that on the other side of this conversion factor so we can cancel it out. All right, we want moles of that same substance, which is H2. The conversion factor is 22.4 liters. It doesn't state it, but at this point we haven't learned about changing temperature or pressure of gases, so we're going to assume that all of these gases are at STP, the standard temperature and pressure, right? And that's the only condition this conversion factor works at. Now that we have moles, we can change it to the desired substance. Right? We're going to use what's called a mole-mole ratio. All right, we're going to get rid of moles of hydrogen and get the substance we want. All right, to get rid of a unit, we got to put that on the other. Sorry, it's not one. We've got to put that on the other side of the conversion factor. So we need moles of H2 on the denominator to cancel out, and moles of the desired substance on the other side of that. All right, the question is asking us to find information about PH3, so we need that on the other side now. The coefficients will give you the mole ratio. Right? There's a 4 to 6 ratio between those two substances. All right, finally, the last step is to convert to the desired unit of that desired substance. So the question is asking how many liters. All right, so we have moles of phosphine. Our last step is to get rid of moles and end up with liters. Right, and you should check, make sure this is a gas. All right, it is a gas. This is a gas. These are gases, and we're going to assume that they're STP. So give myself a little more room. So then this conversion factor is valid. All right, let's punch these numbers in our calculator. Okay, similar to our last one, you can see these are going to cancel out. So we can just put in our calculator 0.42 times 4 divided by 6. And I get 0.28, which is fine because we need 2 sig figs anyway. All right, 0.28. All right, and the remaining unit is liters of phosphine, liters of pH. Oh, wait a minute, I made a spelling error. This should be 3. Sorry about that, pH3. All right, not pH4.